Okay, fantastic. All right. So, as I mentioned, as some of us were coming in, this is a very big and very busy week for the design and construction community. We have two major conferences going on right now. And one is the LCI conference, Lean Construction Institute, which they have a big conference that they do every year, and that takes out a lot of the designers and some GCs and architects and even owners. And it's pretty large. And so we have a lot of people out on that conference. And then next week we have the pre-construction conference, which is very large, and that takes out a lot of the mostly general contractors and subcontractors in our industry nationally. And so we have a lot of folks traveling today or getting things situated. So because it's a week long, and the LCI is just wrapping up. I think it wrapped up this afternoon. So it'll be a pretty light day. And um, as such, Patrick Duke is not able to make it because he's on a plane right now going to the pre-construction conference. So so what I thought I would do is we're just kind of touch in a little bit and maybe um, uh, talk. What I was thinking is something when discuss on how we're going to organize the paper because we're now it's starting to become real and we're getting substantial work in and we're getting close with the master theory as far as explaining it. Expect to have that in a secondary review hopefully by the end of next week. And then I think that's when we'll share it with the group, not wait until it's out of final review. So then we can, have comment on it. Um, Ireland, I'm really glad that and Steve, thank you for introducing us to Ireland. She did a great job on her presentation last Friday, and as well as Rivka. And Rivka's been with the group for quite some time now, a very prominent member of the group, and she's doing great work, obviously. And we saw that with her presentation last week. Um, Ireland, what I really liked about your presentation is it illustrated the importance in estimating to articulate not just the thing, not just the thing, but all of the resource needed that it needs to function. Peripheral, we call it peripheral causality in the physics of estimating, and I thought that was a really good reminder, not only reminder but case study of how we would achieve such level of detail when there is no detail. And so thank you. It was relevant and it's absolutely timely. Rivka, I that's why I'm excited to have you guys also discuss or present at UC Davis. Rivka, I thoroughly enjoyed your presentation as well. I knew I was getting into because I had read your paper and it's being reviewed right now. Should I don't see Jay Lunn on the line, but he's reviewing your paper, and and it's a fun read, as I've mentioned before. But there's something else that I really thought was outstanding when you presented. And again, when you presented, you showed where your paper, your concept or approach of your analysis, where that fits in the master estimate. And I thought that that's actually a good way to organize these papers because we all have expertise, and it's a little maybe different than other papers. Where I'm on a paper with Dr. Hong Nguyen and Dr. Iris Tomlin with UC Berkeley on model assembly and estimating, and it's a little different. Each section wasn't written separately. It was more of a collaborative thing. And well, we have so many expert uh, subject matter experts that I can, or it's very similar to, you an ear doc or eye, nose, and throat doctor, or a brain doctor, or a heart surgeon, or a knee surgeon, or whatever. Everyone has their expertise. And so it allows us to really expand on that flow, and that flow isn't locked because obviously as we get into that can change. But the important thing that I wanted to bring up is what I appreciated about Rivka's presentation is showing exactly where it fits into that theory. And I think in reflection, I think that truly will keep us, as all of us have a different way to look at this, uh, but for a common uniformity to the process, it's going to be really important to understand how it fits. So maybe next week I'd like to talk about maybe two things: is the standard form of how we make sure that it fits within the master theory flow, and then also probably get a little bit more technical on what is a unit, and how does a unit uh, talk to all different aspects of the master flow. And I think, and I'll set in thought anyway. I'll set we'll send out an agenda a little more in advance for next week, and I'd like to have a philosophical discussion about that, because I think it's very relevant as we start moving now through all of these different systems that will have to interact with a master estimate system. Um, so I'm going to pause there. And are there any questions right now, or any observations? Okay. Um, so let me think. Let me see if Jay Lunn is online here. I don't think 1, 2, 3. No, he's not. And again, I knew that today would be kind of a light day. Steve, is there any thoughts that you have, or you're always someone that kind of takes you propel the group quite often to another level, and I'm just wondering what's going through your mind. Is there anything that you feel is relevant that we should be addressing here, short term or long term?
Well, I think one thing that I noted at the last meeting when you were going through the model that was originally, a sketch on the blackboard turned into a drawing is
Right.
we it probably should be built as a more formal model. I'm thinking probably like a SysML model, like a system, like formal system. And it reminded me of it because I actually got access this morning to a new AI design tool. Well, in fact, I'll put
Oh.
the link in the chat. They have a free trial. It is neat stuff that I think you may be able to literally just drag and drop your graphic in
That's
there, and it
beautiful.
will build a model for you.
That is so
Um,
cool. You know what?
um,
Yeah, uh, d- Steve, this is what I'm going to do. I'm going to work. We'll have it. If you can give me that, I got it right now.
Yep, I put it right there. They have a free trial. We're actively working with it. It's still a work in progress. It is not
Yeah.
a full 100% solution yet, but
Yeah.
uh, shoot, I've had it sitting modeling one of my processes for the last 2 hours, hopping on and off because AIs now, you give it a prompt and you come back 20 minutes later when it's done.
Yeah. Well, here's what I'm
But
thinking.
anyway,
Here's what I'm thinking, because the students learn that process in that advanced study where we have 10 or 12, and they've all gone through ECI 181 estimating analysis, and then they're handpicked. Just because they want to do it doesn't mean they'll be accepted. And they go through a review, and then, if we're a contributor or not a contributor, and on and on. And so I'm pretty proud of these students. And I think this would be a beautiful, productive thing to work with the students on, where I'll take the lead on it. But I think I'm going to experiment it, experiment with it where we'll put it into AI, see the output, and then we'll, as a class, we'll go through each step and see how it did or did not do it. I think it would be a because they're starting to dabble in AI analysis on in estimating. So I think
Hmm.
this would be great.
Yeah, and this here, I think this might be a good collaboration, even within UC Davis, with your systems engineering department,
Ah,
talking with them about modeling
yeah,
these as systems engineering models.
yeah. So two on all fronts, bingo. I think you're right. And the other thing is, which is a problem right now, is because it's more abstract flow, it's less understandable than if we had it in a system model, engineering system
Yeah, well,
model.
I mean, not necessarily. I mean, the system model won't necessarily make it clearer to a person,
Hmm.
but it does. There are benefits to it. Otherwise, we wouldn't be doing it.
Yeah, that's awesome.
For
When you
that,
say
and
there's other benefits, or we wouldn't be doing it, what? Why don't you elaborate on that?
well, the systems model, it hooks into the other processes. It gives you checks and balances, and especially with model-based systems engineering, all of this is connected and interconnected. And as we transition more into a automated environment where the AIs are doing more and more of the uh, not necessarily the modeling themselves, but a lot of the analysis and everything else, it all starts to interconnect. And having those uh, machine readable models is important,
Yeah.
because right now your Blackboard model is human readable, and even that, I mean, you got to stare at it a long time before it makes sense.
Yeah.
So this, it also gives you the opportunity to embed a lot more detail in the model. So if you're not sure, you click on it, you just pull out more detail, you can dive in and out. I think you'd have fun doing analysis on it, because once you have that
Yeah.
model built, yeah, you can do a lot with it. Now, systems engineering is an important field. NASA uses it a ton. We don't use it as much as we should. I don't think it's used nearly enough out in industry.
I'm really
It's
liking what I'm hearing,
personal
man.
opinion.
Yeah. No, I absolutely.
The Yeah, the other thing I want to talk about is talk to AECOM. They a couple of their execs on the tunneling side, like the mega project tunneling side, reached out to me to meet with at LSIC. Unfortunately, wasn't able to go to LSIC this week, but I responded back with some questions about their processes, and oh man, they gave me an awesome dump of information on
Mm,
the model-based engineering and digital twins and where some of the gaps are.
mm,
And I don't want to share it word for word, because I don't know how much of that is proprietary that they're sharing with NASA but wouldn't share publicly.
yeah.
um, but they did mention, and I did want to bring this up, 4D and 5D BIM.
Yes.
So
Yeah.
4D, I mean, that's being used a lot, cooking and scheduling. 5D, they're referring to the cost estimation, building that
Yeah.
directly into the model. That's not a term I have heard much. So I wanted to pass
Yeah.
that along. I'm
So
interactively using it.
yeah, so in the construction industry, we're used to 4 and 5, and then they're coming up with
Okay.
6 and 7, which is downstream, all the way through decommissioning,
Hmm.
um, but they just keep numbering, so facilities is another dimension there. And but 5D, I think 4 and 5, I think, are pretty much baked in the cake with our current theory.
Okay.
But you do come up with another thing that we need to really think about is the other advancements beyond 5D that I think we need to consider, at least address. Um,
Yeah, and I mean that's stuff I'm working on as my time allows, and not necessarily trying to build coalitions, but trying to find the answers. I'm a bit agnostic on how we get those answers. I just want to know what methods should I be using, and how do I implement them here at NASA Langley.
yeah. I have a question, Steve. Do you oh, good. Eli. That's perfect.
Yeah,
Yeah, Eli.
yeah, yeah. You like,
So Eli,
yeah,
Go ahead, Steve. I'm sorry.
Hey,
Oh,
sorry.
no, I was going to say our contractors here are using like 4D for scheduling for some of the projects, not all the projects. We're extensively
Yeah.
using BIM. Maybe about half of them use 4D, but I don't think they're using 5D at all yet. They're
No,
still using pretty conventional methods.
hey Steve, my name's Eli. Nice to meet you guys.
Nice to
Sorry,
meet you.
just joined the group and very excited to be part of this research and more than that, hopefully. So just high level. So I've done a 5D planning before, and it came through the schedule. So it was a company where we self-performed almost every scope. So we had the level of detail of equipment, material, idle time. Everything was planned on P6, and then that P6 schedule is what was linked to the model. So it's a lot easier to connect the cost with the schedule than the cost with the bill model. That was the. And I'm happy to share more about how the approach we
Oh.
took with it. But if you just keep like the schedule tied to budget, then
Mhm.
linking the schedule to the BIM model is a lot easier. That's how you achieve the 5D
Okay.
schedule. But you have to have that level of detail of, okay, what does each activity cost? What does each day labor cost? This equipment rental broken down to the day. So it was a heavy data gathering exercise. But once you
Mm.
have it, it was very easy to simulate differences. And we were actually able to like optimize the schedule, bringing the duration lower, and like we were accelerating the project, and we saved a couple of $1 million just because the GCs were more expensive than the accelerations we did. So
Oh, that's interesting.
yeah, there's a lot of
Yeah, because I
advantages
was
to
kind
it.
of imagining
Yeah,
the workflow would go like from the BIM and the MEP models that they would kind of build the cost estimate, and then you'd probably pull that into the project schedule via query that you just break it down by time frame or by work breakdown structure.
yeah,
Because once you have that, you can query it however you want to build your
Well,
reports.
if I may, I think this was really good timing, Eli.
Yeah, it's a sidebar.
Yeah, yeah, but this is perfect because these are the type of things we'll need to address, and you've opened up a whole other dimension of things that we really have to discuss, and I would kind of remind you know we're um we're in a situation on Lunar that everything is production, everything is time,
yes,
everything is time, and because it's tied to resources. And I would say, Eli and Steve, I think we should really think about that sequence. And I can see, Eli, because I know you're a schedule expert.
mm,
Um, and I would probably challenge us to discuss, think about flow. I can see what you mean by, a 5D comes out of 4D. Um, but where my mind's kind of thinking is maybe at the very beginning, because remember we're doing detailed micro estimating very, very early.
yeah,
And so there may be a flow that the estimate, uh, you know, cost wise may be slightly ahead of schedule. But when you talk about costs, I think we should probably delineate something. There's two things going on. There's the line item and the unit understanding the scope and the detail. Then once that is thoroughly understood, then we figure out, what the cost of that is. It's not, yeah, you can't do the cart before the horse. And so I think there's this going to be this dance, this interplay that's going to be very interesting to dive into. And I'm actually pretty excited about this topic that just came up. So um,
Good stuff.
it is. It is.
And I apologize, leave my camera off. Every time I turn it on my work computer, it tends to crash my work computer.
Yeah, I've been noticing a lot of that today. I've been in a lot of meetings today, and the internet seems to be slow today for whatever reason. Steve, I think this is relevant, and where we understand the group as a whole understands the importance of integration into twin models and or digital twins and predictive models and engineering models, and this is such a technical, heavy load on estimating. It's going to be a very exciting journey to prove out estimating flow. And I want to remind John Lunn, who's a student at UC Davis, engineering student. He's been on the group for quite some time. He's developing a mission statement for us because he's been with the group for as a student for quite some time. And one of the things that we were reviewing that the other day for lunch, and it's not quite ready to for us to review and tweak, but it's getting there. And one of the things that I wanted to remind the group is really what we're achieving is absolute minimum variance to predicted state. And I think that's something that all of these discussions that we're having are helping us achieve that. And if we think about that, absolute minimum variance to a predicted state, which means we're going to try to get in the prediction, you're going to try to get as minimal variance as possible, hopefully zero, but is that realistic? I don't know. So I think all of this that we're talking about today with interaction and integration into all of these different types of systems and process is extremely relevant. So my question is, Steve, you brought this up, and Eli, you chimed right in with articulate ease. And I'm wondering if how we address this, um, how we begin to address this in our paper. And as I mentioned before, Steve, that I think that's a weak point within, we have experts within all those expertise parts of the holistic aspect of what we're trying to achieve. But that interconnectability is, other than coding on each line, which we address,
Mm.
that's where I think we have to start putting some brain power in, and maybe assigning some folks to maybe write in that manner. And do you have any suggestions of where we would go from here based on that?
Hmm. Well, if we do look at it from a systems engineering perspective, and I'm going to because I'm a systems engineer,
Is your
the SysML model can handle all those links. So that's really your Bible, your guidance that you put everything in there as requirements, and that can help you link. Now, whenever we start to get more complicated into different systems, like when we're trying to have a mechanical system coordinate with an electrical system, and they're
right?
all portions of the same design, that starts to get very complicated and frontier science. That there are some projects and systems that are using it, but not much yet where there are very few full multidisciplinary interconnected models.
Mhm.
We have trying to, I'm forgetting the word all of a sudden. I've been blanking the word. It'll come to me in a moment. Um, interoperability standards. Sorry, I don't know why I froze on out.
Mhm.
So interoperability standards are the schemas, the methods, that ontology of how systems agree to talk to each other, so we can talk to normally incompatible systems using those interoperability standards.
Mhm.
And oftentimes we talk about it like STEP and like STEP files. That's an interoperability standard for mechanical designs. We use that a lot for like 3D printers and stuff and models.
Mhm.
But that can't talk to electrical. But yeah, just about anything will take a STEP file. So there's some work to be seen there of like if those standards don't yet exist, we could potentially build those standards to connect those pieces together.
Yeah, yeah. That's fascinating. And I really think that is our I don't want to say risk. It's not a risk, of course. It's a risk of not achieving absolute minimum variance to predicted state. If you're predicting something and cost and time so complex, it's a risk if we don't have that interoperability, as you mentioned. I think
Yeah, because
that's going to
these
be
interact, and then I think really what you're talking about is a lot of like uncertainty quantification.
yes, yeah.
Yeah, which I was trying to pull it up because there are some models frameworks. I know one of my colleagues here at Langley was doing a lot of integrated systems analysis work for aerospace, and they
Mhm.
done some great research. I'll see if I can
There's
find
another
some
there,
good papers on
there's
it.
another gentleman. I met him at one of the else or the LISIC. It was a spring. I was there a couple years ago, I think, and I met him. He's one of your head scientists. It's Dr. Figaro, and he wrote a paper. It's on using NASA's G2 system,
Hmm.
and he showed we were, kind of sharing each other's work, and he spent some time explaining his work. To me, that was like almost the holy grail of integration. And I've been trying to reach out to him for quite some time. We had a great discussion, but I guess he's pretty busy. And he replied to me once and said, "I'm sorry, I've been so busy," and but then we haven't connected since. And the beautiful thing about that is that that's work that's already going on, and that was 3 years ago or no, 2 years ago, and he's been developing that, and that's a NASA integration tool, and or at least he's working on it. The G2 probably isn't NASA, but he's working on modifying it for asset management that integrates all systems together, and it's really
Oh,
fascinating.
you mean Gulfstream 2? CG2?
What's that?
You're referring to a Gulfstream jet?
No,
Oh, yes. Oh, okay.
no. He's using it to experiment with resource management.
Oh, okay.
And where everything is tied into a master system and he was convinced that you could tie a sophisticated estimate into where it's like a neural net almost. It's where all of this input's coming in from different sensories and processes and indicates the reality of what it is and what it was supposed to be. And anyways, very fascinating. And boy, I would sure love if he could. His last name is it's Dr. Figaro. He's with NASA. I can't believe I forgot his first name, but his paper, but it's a very short paper we have on our data page as a required reading, but it's a very short paper, and his expanded definitions and discussion is what intrigued me. The paper is very good, but it's limited on how it would benefit this process. But what I liked about it, it was a NASA developed ideology that I think would be a great a communicator with all the different types of systems going in. Keeps NASA in control. So
Um, Paul, if I can share an idea.
yeah, sure, please. That's what this is all about.
Yeah, thank you. So if you think of like construction here, the condition of the soil will impact if we have piles, the sequencing of the pile driving, the dewatering system. But there is that interconnectivity does exist from scope division to scope division. And I don't think anyone, I mean, I'm at least from what I'm aware of, I haven't seen someone who has like really mapped the connections, but it's something that we can build, one scope at a time and how it ties to the next one and the next one. And it to me, it sounds like this is the kind of system that you're discussing, right?
I think it's connected, Eli. I think you are
Okay.
correct. I'm thinking because in my mind, I think we've had discussion stuff. We can see the build of the estimate, and
Yeah.
And as I'm not sure if you saw Ireland's presentation
I did.
that type of
Yeah.
modeling, but it illustrates the importance of understanding micro detail. And why you need micro detail is you got to predict something. Just because it's not there doesn't mean you can't. You still have to predict it. And so I think there's that build, but then there's the downstream where now we're in reality occurring and verification standpoint of what's occurring and what was the original predictive state. And
Yes.
that type of interconnectability, feeds back at the beginning. And I think we all should be aware or remember that construction on lunar surface, it won't be like here at a hospital. Okay, you got everyone's
Yeah.
ready to go. Let's go build. It's going to be very meticulous where they'll do test modules and little
Mhm.
rehearsals and what have you. And so all of that information would have to get fed back into what really happened. What did we predict for production, or the units that we predicted, and what actually occurred. And I think because there is no production no historical or very little historical data on this type of extreme, it's going to be important that that verification and feedback into the master estimate is very sophisticated, because we have to be very sophisticated very, very quickly on prediction of cost or time.
Yeah. Yeah.
Um, but I think you're on the right track, and I like where you're going, absolutely, or where you are. But I think we also have to think holistically, like where you are with that aspect, and then just continuing it all the way through as a continuum.
That may actually be a lot easier with robots because with people, it's often hard to track how much time they spend on a given task. With robots, you know exactly how much time they spend on a given task because, I mean, you can pull that straight from their software and their logs.
I have a
And you
question
can
for
use
you,
that
Steve.
to
Uh,
refine.
I
Yes.
I would agree, but I have a question for you. If a manufacturing plant, I hear you, if a manufacturing plant was out of a conditioned space and on a linear or a lunar surface, with regolith and all that stuff, would we truly be able to predict as we do, control conditions here on Earth? Uh, I don't know. Is it going to be easy? Maybe
I
it'll
think
be easier, but
well, certain things will be easier, certain things will
yeah,
be not be. But I think as far as tracking how much time they spend on different tasks, I think that would be
interesting.
easier just because robots are easier to log and track than
Yeah,
workers.
I see where you're
And I
going with
couldn't
that.
tell you how much time I spent on a particular given task today. I just did
Yeah,
it. But
I hear you. Yeah, that's a good point. Like every second that is being in
yeah, actually,
action.
that may be another good point for your work breakdown structure and stuff like. I'm just thinking like uh, AI API keys. I mean,
Mm,
if you're able to assign a different API key to a different task, then it can tell. I mean, it'll tell you exactly how many tokens you consume because that's how they charge you, and you can track those specific costs really, like to the sub-cent level.
yeah, I think you're exactly. I think that's a bingo. And what I like about the master theory right now, and again, can be tweaked as we need it, but is that it does emphasize the importance of articulation in great detail of coding. And I'm not talking about computer coding. It's more like CSI or a uniformat or excuse me, my mind just went blank. Eli, what's the other one? It's the
Master format
no,
or CSI.
Oh, it's
Oh,
the BIM model one.
yeah,
How can I forget it? Oh, it
I'm
has
blanking on it.
spatial in it.
Oh,
Omniclass.
OmniClass. Yeah,
Yeah. Sorry, I had a
that's
brain seizure there. But at any rate, so there is an opportunity to, I think we were talking about this earlier, is if this is something and they have all of these pieces and stuff that are put together, but then when it's on its journey for construction, it goes lifts off. It's it's a payload, and then it gets deployed and it gets staged and then applied. Every nook and cranny that's included in the estimate would have in its code an understanding of where it needs to be, when it needs to be, and exactly how it needs to be there. And each thing would be a unit. So not only it would be contained in a unit, um, but
mm,
but then you have assemblies within it that have the exact same thing, and it's all code. So I like Steve's suggestion as if there was a robot that, not if there was, there will be, but as that task is being performed, they are placing that unit for a very specific thing. Therefore, is a feedback to, beginning a loop at to the original prediction. But I really like where this is going. Steve, I see
Um,
you. Go ahead. Sorry.
oh no, I'll just kind of continue my thought because I like because your costs, like the majority of your costs are fixed and kind of stop whenever you launch the rocket. I mean, you still have some terrestrial. I mean, you've got operational
Yeah.
costs. You're going to have people on Earth monitoring it. I guess potentially astronauts. But if it is a fully autonomous construction project, then your cost estimate basically ends when you load the rocket.
I, but
What you're looking at after that is really more of a productivity estimate.
Yeah, agreed. But
yeah.
resources. So I have a question for you, Steve. I agree with what you just said, but my question will be, is that a cost here on Earth construction is material, which is easy, not risky, because material usually is the material. But all risks and variables usually are because of time and resources needed. And I think one could argue, you know, robots have a finite time, resources have a finite time because it takes so much planning to get all resources out there. I would say that it's a different type of cost tracking at that point. Uh,
Yeah, it's a lot of R&D. I mean, your shipping costs are one of the dominant costs. I mean,
right.
that alone is different than we have on Earth.
Yeah,
Ireland could
yeah,
probably quantify that a little bit better, but I'd imagine most of it is the shipping costs and then the R&D necessary to minimize your shipping costs and
right.
still accomplish your goal.
Well, this is an important subject, and so I want to ask you another question because I think you're the expert matter on this phone on this specific category. I have a question for you. We've established as a fundamental thinking that the physical cost, the material cost, is inert and figured out when once it's a payload because it's insured. So there's a verifiable audit of what it costs. There's a project, people sign contracts, they get checks, and they build these unique things and invent technologies to do X. And then they manufacture the material and then it gets planned and put on as a payload. Then that is insured by an insurance company and it's insured for X. I would say that at that point that there should be no necessarily argument in what that cost was. It is or it is not. From
Yeah, well,
that,
at that point, I mean, I think that is all spent. I mean, that is all costed at that point.
right,
I mean,
agreed. Yeah,
I think you may need to be careful to separate value from cost because insurance doesn't necessarily equal cost. Um, But
It's a good point.
up to that point, I think your accounting is probably, I mean, if you're keeping track, it should be pretty close. Yeah, the unknowns would then, be, production and uh, the human operation labor that you'd be providing, like
Yeah.
the marginal costs.
Yeah, and what I'm thinking is then that's where it moves into more of a an XYZ trackable where it turns into spatial at that point. Production, um, you know, risks that are predicted or not predicted, and that's where I'm going, and I think that's where your unknown. I mean, sure, the original or the initial estimating is going to be actually quite tricky, of course, because it's extreme. But when it gets into its implementation mode or execution, I think at least from my experience, not lunar, but just in complex projects here on Earth, that is where time is money, and it can turn bad very quickly. Um, that's where my mind's kind of going.
Well, I have something to add to something that Steve said before about, the autonomous equipment
Mm,
being able to track a lot better. And so here on Earth, and I touched on this a little bit last week, that the data problem is real. One of the most difficult things on a construction site is to actually gather production data real time.
mhm.
And I've seen those reports come back, and the most difficult, even the ones that are great, the best you can expect out of the crews in the field is, I did XYZ today. And they'll give you a list of things, but breaking it apart, how long did it take you to put in the structure? How long did it take you to put in the pipe when it was X, depth? That is, I, I, I have never seen anyone do that efficiently, at least from my experience, in civil estimating. And so I think that in a situation where it's so crucial to break down tasks to very minute details, autonomous equipment is going to actually be a very big help.
Yeah.
Rivka,
I, yeah.
just an aside, have you seen any attempts to like put up cameras or stuff or monitor and then break down the tasks, on a more granular basis from those observations?
I mean,
So
it's. I mean, even
the,
if you have cameras and you watch it, right? So, for example, I mean, I get very, very detailed when I do my estimating, and I want to know, for example, how long does it take you? Let's say if I'm going to change just one variable, right? Let's say I'm going to use the same type of pipe, and everything is going to be the same, but it keeps getting deeper and deeper, and sometimes shallower as you go. It keeps, the depth keeps changing. In order to get a good unit number, I have to know, let's say within 2 foot increments, how much can you put in if it's 6 to 8 feet? How much can you put in if it's 8 to 10 feet deep? And that is a hard thing to track. I mean, you're not going to see that from a camera. It has to be very, very detailed data collection, because you could put in, let's say, 100 foot length of pipe, and it's a certain depth on one end and a certain depth on the other end. So typically the people working in the field, they're not going to break down the data in the way that the estimator wants to know it.
You know what's interesting? I think that's really a valuable and timely comment, Rivka. What reminds me of two things is I tell colleagues and students here that in when we talk about Earth estimating, don't count the screws. It's irrelevant. But on lunar construction estimating and production tracking, not only do we need to count the screws, we need to count and predict how many times we turn the screw, because everything has to be calculated and rehearsed, and every screw is going to probably have a very specific, it's specially made for a very specific purpose, for a very specific tolerance. And and so it reminds me of how important this type of tracking is going to be. Steve, you made a comment about do we set up cameras and what have you, and the answer is yes. There's a lot of good work with cameras and AI where they're tracking the movement of workers in production, and also they're using that actually to predict safety as well. How are they interacting with material, things of that nature. But there's also lasers that will come in and do real-time assessments of what's going on. Now, with that said, humans can't be in proximity of these type of lasers. They're experimenting with more powerful lasers. And unfortunately, there's been some injuries on injuries on large projects here lately because they're experimenting to get stronger lasers, but unfortunately, that's not good for eyes. And as a matter of fact, a dear colleague of mine had some eye damage because he walked into a room and they were experimenting with it was a live construction site, and it injured his eye, and it's going to take a while to heal, if at all. Point being is that in robots and that type of stuff, you don't necessarily maybe need to worry about, those type of lasers, or the astronauts can have some sort of perhaps a visor that they don't have to worry about the strength of
Oh,
lasers.
yeah, I think we would. In fact, we're going to have to, because we're going to have a lot of the stuff we're using for lunar has a lot of high-powered lasers in it.
I see.
Um,
Yeah.
Even just the comms have high-powered lasers. But
Yeah.
yeah,
Interesting.
we have a lot of safety stuff here related to lasers too. But
Yeah.
back to your other comment, I did want to. So I do not disagree that we're going to have to count every screw and every turn of the screw. My question is why? Why is it important for on the moon but not important on Earth? What what is different?
Well, this, at least in my mind, I'd like to hear from the group. And this is a very good question. And it's an exciting question. It's fun to postulate on this. And from my viewpoint, and again, 30 years from mine of cost, is the difference is resources and the law of diminishing return. The law of diminishing return states here, or you can apply it to here on Earth, we don't need to count the screws because we just need to be close enough. It's included, the screws are all the same. We build a lot of hospitals or energy plants or whatever it is, and we know what the assemblies are. We can go to a catalog and order. You drop a screw, no problem, just put another one in. There's less uh, connection to catastrophic failure here on Earth and that type of thing. So law of diminishing return is just it's white noise. It has no relevance necessarily. Well, and if, by the way, if you run out of screws, you jokingly, you call Home Depot and off you go and you get it very quickly. Well, um, as our early discussions in this group, we were discussing the magnitude of resource planning has to be in an extreme in extreme, and every screw and how it connects and what it does, it's important to the entire system. And so your meter of law of diminishing return completely changes for the extreme conditions and the supply chain that needs to occur when you're doing it. And we did a calculation early on by using the estimated cost of the International Space Station per astronaut, did some modifications to that. applied escalation factors to when it was done, and some modification factors for lunar. And we determined about a year ago, year and a half ago, that approximately every astronaut will cost $2 million a day, just in support of having them there. And so time then is money, resources, things of that nature. But it is a intriguing question, Steve. But that's why I would say you need to practice and count everything.
Yeah, you had me thinking when you said that. You had me thinking that why? Because it's not instantly obvious. I don't think. I was hoping everybody took that as a rhetorical question too, or maybe not a
Yeah.
rhetorical question, but a question to ponder. I'm thinking it actually comes down to consequences, and like you said,
Mm,
the law of diminishing returns. But really, on Earth, if you overestimate, it doesn't matter because screws are cheap. If you underestimate, it doesn't matter because screws are readily available. You can always get more. That what really matters is the amount of time, just in general, for it. And it would cost us more money to precisely calculate those things out than it's worth for the estimate. For us, it's more economical, I think, just to use the assembly cost.
yeah,
X 1.2 hours for this item. We don't break it down further.
right.
But it was why does it suddenly become important? Why wouldn't we use the same methods for space? And maybe we would. Maybe we would. Maybe we don't need to count the number of turns of the screw, just the assembly time for it. We just need to make sure that we ship the right number of screws, because
Yeah,
the shipping cost for shipping extra is very high, because
yeah.
every ounce of weight matters. And if we don't ship enough, that's critical too, because it's very hard to get more.
Yeah, but think about this, that when I agree with you, maybe it's hybrid, and some of me speaks in hyperbole when I say count every turn, but it illustrates the importance of
No, I think you're right.
cause
I
and
think you're
effect.
right with that.
Yeah.
But I think because we're breaking it down to that level, because we don't have, dozens of years of, we've installed
Bingo.
500 of these and they
Yeah.
took X number of time. Where this is
Yeah.
this is all brand new.
Yeah. And as we get more, I think you're exactly right. As they start maturing a lunar economy, we'll have that type of data, and maybe at some point that law of diminishing return threshold starts moving down.
Also,
Yeah, I think you're absolutely right.
another thing about this is, and maybe it's not exactly, specifically estimating, but it kind of ties in, is when you track things, especially when you track things in an interconnected way, patterns start emerging.
Ah, ooh, yeah.
Learn how to do things more efficiently just by.
Mm, good comment.
Yeah,
Very,
excellent comment.
that's a good one. Sampata, you have a comment.
Uh,
Yeah, I actually had a question. I mean, since we are talking about like creating these estimating systems, do we know for sure what the means and methods would be, or even have an idea so that, you know, that could be formulated and inculcated into the estimate?
If I could take a stab at this first. I'm looking at the time, and I appreciate the conversation, but we can stick on until we feel everyone can leave at their own accord, but we're in a good conversation. Very good question. And the way that we've approached it in the theory and discussions in this group is that the estimate starts formulating with the maturity of design and intent. And so as the technology is being developed, as use cases are starting to emerge, the estimate matures with the current state of design and intent and engineering. But the estimate will be a projection of the future in much more detail than the design and engineering of that function. So,
Mm.
so the estimate will be a true projection of future state in a very detailed way. And so when we're talking about the verification step on lunar surface in production, we would have that same verification step during manufacturing and technology changes of systems. So it will be important that those type of connectability sensors and reads as design is progressing, that it's those also affect the predicted state of the estimate. The most important thing is that the estimate is not an inert system, that it's active. And that way we have continuity from the very beginning. Of course, it changes, but we have continuity at the beginning, during execution, and then we truly have an opportunity to learn very fast on, as Steve was mentioning, that level of threshold for law of diminishing return based on historical. Um,
Mhm.
Can I just add something, Paul, to that?
please, please, please.
I think we should look at each scope division as its own recipe, like cooking
Mm,
recipe. Because if you
yeah.
think about it, to schedules today, they have an activity that's 20 days that says bake the cake. But if we break that recipe down to add this much water and turn the screw this much, each of these hardwares has 6 lag bolts. And break it down to that level where we can also anticipate what factors could impact each
Mm,
mini step within the recipe. I don't think
right.
you need that many sensors. Then you're just looking for a set of factors that we could probably simulate today if we have that level of detail.
Let me ask.
Uh,
I
Yeah,
think you're
I
right
agree.
on. Yeah, I have a question for you. Uh, if we don't track tool, and I agree with, I'm not disagreeing with what you're saying. I think it's very intuitive. But a question: if we don't over track detail when we're trying to learn, when we're trying to establish a reliable prediction from historical relevance, and there are none, and we're in extreme conditions. So my question would be to the team: if we don't track in hyper micro unit, how would we understand the true risk of probability of it failing or not occurring if we're not tracking in detail? As an example, this is just fictitiously, a hairline crack happens because instead of you turned it 12 times, you turned it
mhm.
13 times. But if we don't know that, how would we be able to even take a risk guess? In other words, perhaps at the beginning, maybe you over track things and then start sifting through the noise that doesn't matter versus the relevance of matter.
I, I think I would look at it again using the same analogy of a recipe. The
Mm.
project is a 20-course menu, and each item has its own recipe, and each recipe has its own impacts.
Yes, I
And
see where you're
that's where
going.
yeah, so that's where you get the interconnectivity because that hairline crack, yeah, it might damage a certain thing, but maybe that's not on the critical path, and maybe fixing it is not as bad as we think and not as costly as we think. So then focusing on that hairline crack might take resources away from where we should be focusing, which is what is the most impactful activity to maintain the schedule, to maintain this production.
Yeah.
Because I mean, you have to anticipate contingency that failures will occur.
Your last bit just cut out, the very last sentence you said. I'd like to see how you concluded that.
Sorry.
What was
On
Uh-oh.
this
Eli, I'm sorry, you're cutting out.
failure.
Yeah. All right. Can you hear me, Eli? Okay. But good content.
Al.
I know I'm not freezing, but Steve, what's your thought on that?
Yeah, he was breaking up for me a little bit too, but
Yeah.
from what I heard,
Yeah.
I was gonna say, yeah, good copy on that, and I think you're right that there's different values to each of those pieces and different risks to each of those pieces, and that needs to be carefully weighed.
Yeah.
That some of this stuff, like on like I think on Hubble was one of the projects where they literally counted every turn of the fasteners because they
Hmm.
knew they had to drive it to a certain amount, and they
Yeah.
knew that they should see a certain amount of torque at different parts of the curve. And if they saw the wrong torque at the wrong point, they knew there was a problem and they would stop, because
Hmm.
the
Interesting.
consequences for overdriving a screw or underdriving a screw were potentially loss of mission of this massive telescope.
Yeah.
Um,
Now,
we see that in some areas, whereas like if I'm installing an electrical panel, I'm just, yeah, how many UGAs does it take? You know, if it's a little
yeah.
bit loose, it doesn't matter. If it's a little bit tight, probably doesn't matter. Maybe we strip the screw and got to replace it. But
Well, Steve, that would come though, that type of a determination of importance necessarily maybe not even come from the articulation of the estimate, but the engineering model, the engineers physically
yes, the
saying,
engineers would
yeah,
assess that risk and say
yeah,
this is important.
agreed.
How because we end up with the whole risk model. Well, what are the risks? This, and then we develop the mitigations. And I can just imagine some systems engineers saying, "Okay, well, we need to put torque censored, turn counting screwdrivers so we can track that torque and those turns to mitigate this particular risk."
Right.
We do that here on Earth with like just torque wrenches. I mean, yeah, if I'm putting the cover on an electrical panel, I don't care so much about the torque. But if I'm bolting a bus bar to the back of it, oh, I absolutely care about that torque. It's,
Sure.
I'm specking that out to the nth degree.
So I'm wondering, and again, it just emphasizes the importance of the engineering model, tying back to the estimate detail, and where there's, when I mentioned each item has a code that tells a story about that line or that thing, and I'm starting to see some really intriguing flow. And it's almost like I'm seeing, where it's an oscillation of feed and output of information.
Yeah,
Um,
but I will say, aside from some of the costs, supply chain costs, particularly being different, labor, well, but the actual physical work that we will be doing for the moon is going to be almost identical to the work we're doing on Earth, and we know a lot about the work that we're doing on Earth.
yeah,
I mean, if we're building electrical systems on the moon, I would expect to treat them the same way we do on Earth, that a screw on an electrical panel is going to matter less than a bolt on the bus bar.
but engineers would determine that, wouldn't they?
Engineers determine that,
Yeah,
yeah. And then it comes down to, what is the cost of doing that? I mean,
yeah.
honestly, here on Earth, I don't necessarily spec that stuff out. It's
Mhm.
just we show it on the panel and we tell them to do it in accordance with manufacturer recommendations, and we expect them to go and pull those recommendations and do it. I don't I mean, we don't go to that nth degree on the drawings because we don't need to.
Yeah. Yeah,
But if we're programming robots to do it, we're going to have to be more explicit.
yeah, yeah. I think this was an absolutely fascinating conversation, and I'm really glad we recorded it. And this will be brought out to the team. And I hesitate to send this recording out to the entire team or the folks that show up on a monthly. But maybe we'll keep it to the core group, and if yeah, or we'll decide if we want to distribute it to the monthly group. I have no preference at this point. Um,
All right. Well, I'm
okay.
going to go. We have a retirement function, and I'm going to go down and see some folks before they leave. And
Awesome. Well, thanks as always. Eli, you're not here. You'll see the recording. Good job. Everyone really contributed well. As always, Steve, it's an honor and a privilege to have these discussions with you, and you always push it forward, as we all do. And so thank you. And I love the fact that we were encouraged to keep with this deep conversation. And I'll see you guys next week.
see you next weekend.
All
Thanks
right.
again.
Bye-bye.
All
Thank
right,
you.
thank you.
Intriguing. Very intriguing. Thank you. Bye.